Good morning, students. Welcome to mathematics class. I am Colin from the Department of Mathematics here at St. Philomena'S PU College. In today's class, we will start with the chapter probability. This chapter is a continuation of the chapter probability which you have already studied in first year PUC. So, the name of the chapter is probability. Before going further, we will see what is the weightage of this chapter for the final examination. So, we have one question asked from part A, that is carrying 1 marks, one question from part B carrying 2 marks, one question from part C carrying 3 marks, and one question from part D carrying 5 marks. So, in total this chapter carries 11 marks. Okay. So, one question from part A, 1 mark, one question from part B, one from part C, and one from part D. Then, before starting with the second PUC syllabus of probability, we will just recall some important concepts which we studied in the first year. The first of those concepts which we studied was that of random experiment. Random experiment. So, what is random experiment? How do we define random experiment? An experiment satisfying 2 conditions. Condition number 1, okay, it has to have more than one possible outcome. Condition number 2, you should not be able to predict the outcome in advance. I repeat the definition. Any experiment satisfying 2 conditions. Condition number 1, it must have more than one possible outcome, and condition number 2, you should not be able to predict the outcome in advance. To illustrate this definition, we will take an example of tossing a fair coin. Okay. So, this is one of the general examples of random experiment. We have already come across this example in the first year itself. Tossing of a fair coin. So, a fair coin has 2 faces. One is heads, the other face being tails, right. So, that is more than one possible outcome. Whenever we toss a fair coin, either you can get a head or a tail. So, that is satisfying the first condition for a random experiment. The second condition, what is the second condition? You should not be able to predict the outcome in advance. So, whenever we toss a fair coin, you will not be able to predict the outcome in advance. So, since this experiment is satisfying both the conditions for a random experiment, this experiment is an example for random experiment. Another example for random experiment that we have already come across is again tossing a fair die. Tossing a fair die. As we all know, a fair die has 6 faces and each face is marked with 1 dot, 2 dots, 3 dots and so on. Okay. So, there are more than one possible outcomes again for this experiment, and the second condition again is that you should not be able to predict the outcome in advance. So, obviously, whenever we toss a fair die, you will not be able to predict the outcome in advance. So, this is another common example for a random experiment. So, this we have already studied. Moving on to the next concept, I am just recalling this. Whatever we have studied in the first PUC, I am again recalling. We have not yet moved to the second PUC syllabus. The next concept is that of sample space. So, what is sample space of a random experiment? Sample space of a random experiment is the set of all possible outcomes of that random experiment. I repeat the definition once again. Sample space of a random experiment is set of all possible outcomes of a random experiment. To illustrate this definition, we will again take another example for a random experiment. We will take the example of, say, tossing two coins. Tossing two coins. Okay. So, again this example for a random experiment we have come across in the first PUC itself. Tossing two fair coins. So, how many total number of outcomes are there for this experiment? We have to think about that. Well, there are totally 4 possible outcomes that you can have for this experiment of tossing two fair coins. Okay. So, the first outcome might be getting 2 heads, right. So, we are having 2 heads on both the coins, first coin as well as the second coin. If I am denoting heads by the symbol capital H and tails by the symbol capital T, okay, and we know that sample space is the set of all possible outcomes. So, I have to write a capital letter of English alphabet because it is a set. I open the flower bracket. So, the first outcome will be 2 heads. So, I will write it as H. H describes getting 2 heads. Heads on the first coin, heads on the second coin. Okay. So, remaining 3 outcomes. What might be the next outcome? HT. Heads on the first coin, tails on the second coin. So, that will be HT. Then tails on the first coin, heads on the second coin. That is TH. And the last one is tails on both the coins. That is, you can denote it as TT. So, I close the flower bracket. So, this is nothing but the set of all possible outcomes of this particular random experiment. That is nothing but the sample space of this random experiment. Okay. One more example. This example also we have already come across. We will take the example of tossing 3 coins. So, this is the example of tossing 3 coins. Again, this is also an example for a random experiment. We shall try to write the sample space of this random experiment. So, I will denote it as capital S. We open the flower bracket because this is a set. How do we write the sample space? How many total outcomes are there? For this experiment, there are totally 8 different outcomes. So, we can start from the outcome wherein we get 3 heads. Again, we are denoting heads by capital H, tails by capital T. So, getting 3 heads is nothing but the outcome H. It is nothing but heads on first, second as well as the third coins. Okay, there is a simple rule. We have 2 symbols. We have an H and we have a T. H changes to T and T changes back to H. Okay, this keeps on going. H we have to change it to T, T we have to change it back to H. Okay, and look at the first outcome. We have 3 heads. We have 3 H's. Okay, we can think of this as the unit place, tens place, hundreds place. And we always change the symbols from the unit place. It is just like writing binary numbers. We have two symbols, we are changing those symbols in a cyclic manner. Okay. So we have H here, H and H. We can think of this as the unit, tens and 100 places. Okay. I start changing from the unit place. So I change, there is an H here, I change it to T. We also have to remember that whenever we are changing from H to T, we should not be making any changes in the symbol to the next higher place. So for example here, I have an H, so I change it to T, okay, but I do not make any changes in the symbols in the higher place value. So this H in the tens place remains as it is, as well as the H in the hundreds place. So the next outcome will be what? H changing to T, H remaining as it is, and H remaining as it is. So that is H, H, T. So that is the next possible outcome. Remaining we have 6 more possible outcomes using the same idea. Okay, we are going to start changing from the units place, and thereafter we are going to write the different possible outcomes. Okay, so look at the unit place of the second outcome. We have a T here. T needs to be changed to an H, right? But the rule is whenever you are changing from T to H, you have to make a change in the next higher place value. Okay, so I am changing T to H. That is why I have to look at the next higher place value, which is the 10th place. In the 10th place, we have the symbol H. So H changes back to T. So T is changing to H in the unit place, and H in the tens place is being changed to tails, T. But since it is a change from H to T in the tens place, we are again not going to make any changes in the hundreds place. So the rule is whenever we are changing from H to T, no change. But whenever we are making changes from T to H, you have to make a change in the next higher place value. Okay, now T changes to H, H therefore changes to T, but this H remains as it is. So the very next outcome is nothing but H, T, H. Okay, so similarly H we change it to T, so the next outcome will be H, T, T. Okay, then following the same method, we are changing from the unit place. What is the next outcome? Correct, it is T, H, H. Then it will be T, H, T. Then it will be T, T, H, and the final outcome is T, T and T. So we have successfully written the sample space of the random experiment tossing 3 coins. So all these are how we are going to write sample spaces for different random experiments we have come across in the first year PUC syllabus. Moving on to the next concept. The next concept that we have studied is that of an event. So what is an event? Any subset of the sample space of a random experiment is said to be an event. I repeat the definition once again. Any subset of the sample space of a random experiment is said to be an event. Okay, we will take the same example of tossing 2 coins. Okay, so the example or the random experiment is tossing 2 coins. In this random experiment, we can think about writing its sample space. What is the sample space? I denote it by capital letter S. S equals, we start from H, 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 then we move to H, H, T, then we have H, T, H, H, T, T, T H H, T H T, T T H, and the last one is T T and T. There are totally 8 possible outcomes. Just now we saw how this works. Okay. Now this is the sample space of the random experiment tossing 2 coins. Okay. Now I will define a situation. Situation E is such that we are getting 3 heads. Okay. If I just say we have a situation wherein we are getting 3 heads, then what are the possible outcomes wherein you are getting 3 heads? So you can see that 3 heads is only, this is the only outcome wherein you are getting 3 head. In the sample space, there is only one outcome where we are getting 3 heads. So I can write set E is equal to the singleton set H, H, H. Okay. So what did we do? Recalling again, we started by taking a random experiment. That random experiment is tossing 2 coins. We wrote the sample space of that random experiment. Then we saw, given a situation E is such that getting 3 heads. Okay. Then we saw which are the outcomes wherein we are getting 3 heads. This is the only outcome wherein we are getting 3 heads. Hence we can write set E as the singleton set H, H, H. So you can see that the definition of an event, any subset of the sample space of a random experiment is said to be an event. Here set E is obviously a subset of the sample space S, making E an event of the sample space S. Okay. One more example, if we have the situation F wherein if I say getting say 2 heads, getting 2 heads. Okay. So that is the situation. The given situation is getting 2 heads. When we look at the sample space again, what are the possible outcomes where we are getting 2 heads? We have to see. So we have 2 heads here, H, H, T, then H, T, H has 2 heads and T, H, H also has 2 heads. These are the only outcomes in the sample space wherein this situation occurs, getting 2 heads. So what might be the set F? Okay, the set associated with this situation, that is nothing but set containing the elements H, H, T, comma, H, T, H, comma, T, H, H. So set F is set containing these 3 elements. So F is an event because set F, the set associated with that situation, is a subset of the sample space S. Okay. This we have already come across, and many other examples for events and different types of events we have already discussed in first PUC. Moving on. The next concept is that of probability of an event. Probability of an event. So as the name itself is saying, probability of an event, you have to have an event and you can find out the probability of that event. Probability of that event is nothing but a particular number associated with each and every event of a sample space. Now, we will take the example of tossing 2 coins. okay, tossing 2 coins. Now, the sample space of this experiment is S equals HH, HT, TH and TT. Okay, we will define 2 events. Say event E is getting 2 heads. Event E is getting 2 heads. So, what will set E be? It will be nothing but singleton H H. Okay. Now, we have got an event, we have written the set associated with that event. Now, look at event E. Probability of event E is denoted by the symbol P of E. Probability of event E is denoted by the symbol P of E. It is nothing but equal to N of E by N of S. So, what is N of E here? N of E is nothing but the number of elements in set E. What is N of S here? N of S is nothing but the number of elements in the sample space S. So, the number of elements in set E is 1 divided by number of elements in sample space, we have 4 elements. So, the number 1 by 4 is called probability of the event E. Another event we will just take, say we have event F getting at most 2 heads, or we will say getting at most 1 head, okay, getting at most 1 head. So, how can we write the set F, or what is the set F getting at the most 1 head? At the most 1 head, meaning you can get exactly 1 head, or you can get 0 heads, no heads also. Okay. So, which are the outcomes wherein you have exactly 1 head? HT and TH, right. So, these are 2 outcomes which are having exactly 1 head. So, those have a place in set F. So, HT and TH, then you can have 0 heads or no heads. So, which is the outcome wherein you have no heads? It is the outcome where you have 2 tails. So, that is TT. So, we will write that outcome here as well. So, this is set F. We have to find out probability of event F. So, probability of event F can be denoted by P of F. P of F similar as to P of E. P of E is N of E by N of S. So, similar to that, P of F is N of F by N of S. Okay. What is N of F? N of F is the number of elements in set F. N of S is number of elements in the sample space. So, number of elements in set F is 3 elements. Number of elements in the sample space is 4 elements. So, the number 3 by 4 is nothing but the probability of event F. So, these things we have already studied in the first PUC syllabus. Then, a few more concepts or results which we have studied regarding probability is this. The first one is P of 5. Okay. Probability of the empty set or the probability of impossible event is always 0. Then, probability of the whole sample space S, that is P of S, it is always equal to 1. Then, if we have say 2 events A and B pertaining to the same sample space S, then probability of the event A or B, that is P of A union B is nothing but equal to P of A plus P of B minus P of A intersection B. This we have already come across, and problems based on these results also we have solved. Then the last one is P of A dash. So this is the event A dash, not A, complementary event of event A. So P of A dash is equal to 1 minus P of A. So all these 4 results and problems based on these we have come across in the first PU syllabus. So these are all the important or basic concepts of probability chapter which you will be needing, which we will be using for second PUC probability chapter. So make a note of these and try to recall it after this class.